We're going to be solving absolute value equations. So we can solve absolute value functions by graphing using the strategies that we learned in 8.1, or we can use solving algebra. So I'm going to be going over graphing them, and then I'm going to be showing you how to do it algebraically as well. The first example, we'll solve by graphing, and then we'll verify the solution. So we've got the absolute value of 3x minus 6 is equal to 6. So just like in 8.1, we would graph the original equation, y equals 3x minus 6. And you can see that this is in y equals mx plus b form. So we can see that negative 6 is our y-intercept. And then we have 3, which is our slope, which is the same as 3 over 1. So I'm going to graph the original, and then I'll make it into absolute value. So I'm just graphing this section right now, whatever is in the absolute value. And then I'll graph this section separately. So we have two equations we'll be graphing. So I'm going to start at negative 6 on my y-intercept. And then I'm going to go up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. There's my original line. It's pretty straight. You go from your critical point, and you do the slope backwards. So you would go up 3 over 1, up 3 over 1, up 3 over 1. So then this becomes our absolute value graph. So I'm just going to make that red, so you can see that's the actual absolute value graph that you want. So really this stuff down here doesn't really exist anymore. So it could be some dotted line down there. So it's just using that original y equals mx plus b line to graph the absolute value line. So just remember a critical point would be at x equals 2. So that is graphing the absolute value of this one here. Now I need to graph this 6 value. So we pretty much have two lines happening. So we have y equals the absolute value of 3x minus 6, and I graph that. And then we have our second line, which is y equals 6. So that's the next line I'm going to graph, and you're looking for where they're intersecting. So you actually have two lines here. So y equals 6, 1, 2, 3, 4, 5, 6 is here. And you're just going to draw y equals 6, which looks like a horizontal line at y equaling to 6. So this graph is going to cross in two spots here. We've got x is 0, y is 6 right here. And then we have this point, which is 4 and 6. We'll plug this in for x just to make sure it actually works in your equation. So we can try putting in 3 times 0 minus 6 should equal 6. 3 times 0 is 0. Negative 6, the absolute value of negative 6 is actually 6, so that works, right? Okay, let's do the next example. We're going to be doing the same thing here, graphing 3 equals the absolute value of 3x squared minus 3. So I'm going to graph y equals the absolute value of 3x squared minus 3. And I'm also going to graph y equals 3. So again, we're going to have two lines happening, or two graphs. And in order to graph this one, we graph the original, which looks like 3x squared minus 3 to start. So we are in vertex form, so we can see that our vertex is 0 and negative 3. I can also factor this to then find my x-intercepts. So let's put 0 and negative 3 on the graph. So because we have the positive 3, this graph is going to open up. So if I put 0 in for y, and if I factor out 3, it can look like that. And I could actually factor that further to x plus 1, x minus 1. So our x-intercepts will be negative 1 and positive 1. I'm just going to do this. Make it dotted for my original. And then I'll make it into an absolute value graph after this. So I take my negative points, so 0, negative 3, and I put it up to become 0, positive 3. And now my graph for absolute value looks like that W. So that is my absolute value function. There's a horizontal graph, horizontal line. For my second one, y equals 3, which is right here. And now you can see that it crosses at 3 different spots. We've got a crossing here, a crossing here, and a crossing here. So it looks like 0 and positive 3. I don't know if that's very accurate or if that's accurate. So what I'm going to do to check to see what my x values actually are, I know that my y value is going to be 3, but I'm going to have a positive one on the right side and a negative one on the left side. I'm just not sure what my actual points are without being able to use the graphing app. So I'll show you what I do here. So this is one solution, and this is what we'll be doing when we solve it algebraically. We're going to make it, I call it like a positive solution, where you take the stuff inside your absolute value and you make it positive to solve for x. So I'm just using the same equation here. I'm just using the positive version from here, which is just leaving it the same. And then I'm going to do it a second time with the negative version, and we're going to solve for x. So when I solve for x here, I'm going to add 3 to both sides. I'm going to isolate my x. And then I can divide by 3. And then I can square root. So x will be 1.4. And really it's going to be positive and negative 1.4, right? So this is probably, x is negative 1.4 and 3. And this one is positive 1.4 and 3 as my solutions. And then this one in the middle is our x is 0 and 3. If you looked at your graph and it looked like that, and you wrote down something close to it, negative 1.2 and 3 and 1.2 and 3, I would accept those as answers as well. So this one, it's a quick graphing one. I can show you a trick to it where you don't have to do a lot of work. So remember we've got the 2 equations. We've got this one, y equals absolute value 2x squared plus 4x minus 1. Oops. And then we have this one where y is equal to negative 2. Now this equation with the absolute value, from what I've been showing you, is it's going to turn out to be some w, right? So it's going to turn out to be something like this, maybe, right? Just sketch a w. Because the most important thing here is that this is y equals negative 2, which is negative 2 down here. So because this is going to be all positives, and this is actually a negative value, they're never going to intersect. So you don't even really have to solve anything. You just have to know that because this is negative 2, my 2 graphs are not going to intersect and they're not going to cross, so then there's going to be no solution. So an absolute value equation of this form can have 0 solutions, 1 solution, 2 solutions, 3 solutions, or 4 solutions. Okay, so here we are with the different solutions. So just like the example I did above, here's my one line, but here's my absolute value. So you can see that they don't touch. So that's why that one has 0 solutions. we have a line that's going here, you can see that they cross here and here, giving you 2 solutions. And then if you have a line that goes through here, we've got 1, 2, 3, 4 solutions. And then if it goes up here, it crosses in 3 parts, so 3 solutions. And then there's a possibility of having 1 solution, so if this is your absolute value function, and then you have the 1 line going here, you can see that there can be 1 solution there as well. So one of the problems with solving problems by graphing is that the solutions are often decimals or they're approximate answers, but we can determine the exact value using algebra. So solving algebraically. So remember how I've talked about absolute values having a positive solution inside them and then a negative? And that was happening when we were talking about the piecewise notation. So when you solve it algebraically, you're going to have 2 solutions. So you're going to do it positive and you're going to do it negative for what's inside the absolute value. So if you're going with what's positive, I would set it up like this. So whatever is in the absolute value would be positive. So that means that that would be greater than or equal to 0 inside my absolute value. So this is making it my positive version. So I would solve for x. There's that imaginary 1 that would go through. So when I solve for x here, I want to put the x's on one side and the numbers on the other. So we could subtract x from both sides. So you're collecting the like terms, but moving it on to the other side as well. And then I would minus 6. And then divide by 3. So now that I see what x is, I need to make sure that it actually is a solution by checking it. So you would check it with this restriction I put up here. So check with restriction to make sure it's actually bigger than 0. So that means I would put that in for x. And this has to turn out to be greater than or equal to 0. So 8 over 3 plus 6 is greater than or equal to 0. You could get a common denominator. It's going to turn out to be just some positive number anyways. So let's just make it 8.67. Just do it in your calculator. Is greater than or equal to 0. You're just checking here, and that's true. So since when you put your x value into your restriction and it does work, it's greater than or equal to 0, 8.67, then it's a solution. So that's one of our solutions. So our negative restriction is what is inside our absolute value to be less than 0. So there's our restriction. And then we're going to put a negative on the outside of what is inside our absolute value. And we're going to make this the negative restriction and then solve for x. So again, there's that imaginary negative 1 now, and that's going to multiply through the brackets. Here's my negative restriction there. So you'll check with that after. So now to solve for x, I would do the same thing and put the x's on the same side, and the numbers on the same side. So this will become 5x plus 8 is equal to negative 6 minus 8 like that, and then divide by 5. Check this with my restriction. So we'd go up and check with the restriction. So I'm just going to do this over here. Put in your x value. And this restriction has to be less than 0. And that's because when things are negative, they're less than 0. And that's why I made my other one greater than or equal to 0, because positive numbers are greater than or equal to 0. So this has to be negative, has to turn out to be negative to actually work with that x value. So negative 14 over 5 times I4 plus 6, I get negative 5.2, which is less than 0. So that's my solution. Okay, the next example, the positive restriction will be 2x squared plus 7x minus 1 greater than or equal to 0. So when we solve this one, this will be positive inside our absolute value, equaling to 3. So everything will stay as positive. And we're going to have to solve for x. So this is my restriction here. Make sure you state that your restriction, everything greater than 0 because it's positive inside the absolute value. So I'm going to minus the 3 to both sides. Combine it with its like term. So now we would have 2x squared plus 7x minus 4. And now I'll be able to factor it since it's equal to 0. So always make sure you're moving things over to make it equal to 0. So 2x squared, I'm going to try 2x times 1x. And then I believe it's negative 1 and positive 4. Remember, we can check by doing 4 times 2x, which is 8x. 1x times negative 1, which gives me 7x. So that means my factors are 2x minus 1 and 1x plus 4. Negative 4 and 1 over 2. And then you would stick those individually back into here to check. So I'm going to check each one. So I would put in 1 over 2 in for x to make sure it turns out to be greater than 0 or equal to. That has to be greater than 0 to be true. So you can just type this all in at once. So that works. And then you'd have to check negative 4 as well. That also turns out to be 3. So negative 4 works as well. So the negative restriction is your 2x squared plus 7x minus 1 would turn out to be negative, so less than 0. So we're going to have the negative in front of that, equaling to 3. So you'd have to make everything negative. And then we could do the same thing and move the 3 over. Now I'm just going to review doing quadratic formula. In case you decide to use quadratic formula, you could if you didn't want to factor. So I'm going to use quadratic formula just so you can see that again. So that's where we have our A, our B, and our C. And you use the formula like this. So you could use this if you wanted to, if you just didn't want to factor, right? So you could always use this formula. So this would become positive 7 plus or minus, I'm just going to say 33 over negative 4. So then you get your two values. So you get x is equal to 7 plus the square root of 33 divided by negative 4. Or you could do 7 minus the square root of 33 divided by negative 4. Negative 3.19. Negative 0.31 to your x values. And then again, you'd stick them back up into your restrictions and check them. Let's say you go and check them up here. you would check them